In this lecture, we define that how we can access different elements from an array. So before going through this section, first I need to explain one more thing that I forgot in first basic implementation of NumPy section. So the thing is, to find the total number of bytes of an array, you need to use this function n bytes. So for example, I let's use n bytes for this single dim. So n bytes. So we define n bytes at int 8. So every element taking 1 bytes, and we have 5 elements. So total we have 5 bytes taken, 5 bytes taken by this whole array. Now let's if we define this to 32 and use this n byte function, so we get 20 because we have 5 element and each element taking 4 bytes. So we take total we have 20 bytes taken by this whole array. So that's how we can calculate the whole size taken by, or total size taken by an array. So let process further in our next section. So how can we access the element of an array? So let's define a 2-dimensional array, for example. So let's define that 2-dim array and use pi dot array. So let's create a little bit longer now. So 3, 4, 7. Now let's run that. So we have a 2 by 8 two row 8 column dimension, so 2 comma 8. So we can ensure that by using the shape of it. So we have 2 rows and 8 columns. Now I have a question for you. How can we access this 5 element, this 5 value in this element? So to access this, what we need to do is just use our array and first define our rows. So the 5th element, or the 5th number, this value is situated in 2nd row and 4th column. So this row and this 4th column. So first we define row which is 1. So indexing start for 0. So for 2nd column we use 1, and the column we want to specify is 3. So indexing start for 0, as I say. So when we run this, we get 5 because 5 is situated in 1st row, this one, and this 4th column, this one. Now how can we access this 3? So 3 is situated in 1st row, so we define 0 here because 1st row, and 1, 2, 3, 4, 5, and this in 5th column, this column, or this 6th column, as we can start from 0. So when I run this, we get 3. So to access a 2-dimensional array, first we need to define the row we want to access, and second we want to define the column we want to access. By defining these two numbers, we can access a particular element in a 2-dimensional array. Now how can we access a list? How can we access a particular row or a particular column? So to get row, what we need to do is, as you know from the list, as you know from the Python list slicing, to get the whole row of a particular 2-dimensional array, you need to use this colon symbol, and you get a particular. So for example, you want to get this 1st row, so you need to use 0 here, and you want to get this all columns, so you use this colon symbol. So by running this, we get our 1st row, because we get our 1st row which is defined by 0, and we get our all column which is defined by this colon symbol, which is defining all. Now for example, you want to you want to fetch only from this starting point. So what you need to do, just use you need to use 2 here. So what happen here is, you fetch your 1st row, but in your 1st row you start fetching from this 2nd column, this 89 column. So this specify from 2 to last. So this is how slicing work in 2-dimensional array in NumPy array. Now if you want to fetch the column or a particular column, full column of a array, what you need to do is just similar as this row concept. So specify column here. So I need to specify this, for example, this third column which contain 89 and 4. So I need to use all the row, because 89 is on first row and 4 is on second row. And I need to specify 2 here, because indexing starts for 0. So let's run this, and we get our this third column by specifying all the row, because this data is this 89 is on 0th row, and this fourth data is on first row. So we define all the row and only second column, and we get our second column data. So that's how we can use slicing to assess the particular elements, particular row and columns of an NumPy array. Now, how can we change something in our NumPy array? So for example, I want to replace 47 with 86 or some other value. So what I need to do is just use, or let's delete this math. I accidentally overhyped this section. So to change this, what you need to do is just first assess the element by this assessing mechanism. So this 47 is on 0th row, in this row, and 1 column, or second column. So 0 and 1 due to 0th indexing, and I need to use 34 here. So when we print this 2-dimensional array again, we get our new array in which 47 is replaced by 34. So that's how we can replace the particular elements from an array by assessing their position by row and columns and changing that value you want to change. Now, as I said in the previous lecture, let's create a 3-dimensional array. So let's add a code block here. So 3 dim. So let's see how can we create a 3-dimensional array. So we need to use nested array. So let's define 4, 5, and 1, 2, 3. When we print this our 3-dimensional array, we get some other type of data. So now first let's print the shape of this NumPy array. So by using this shape functionality, so I type capital here. So we have 2, 2, 3. So what it's indicating here is that we have two big array of this big array, and in each array we have a sub array of 2, 3 dimension. So we have 2 big array or 2 blocks here, and in each blocks we have 2, 3 dimension data, means 2 row 3 column dimension data. Now let me use a different data dimension. So let's use 5 here. And now when we print our shape, we get 2, 2, 5. It means that similarly we have 2 bigger blocks, and in each bigger blocks or bigger array we have a sub array of dimension 2, 5. So 2 row and 5 column. So that's how we define 3-dimension data in our NumPy array. Now this is a little bit complicated for you in starting, but if you keep practicing it, you start into knowing that how this 3-dimension or even 4-dimension data array works. So I am not explaining 4-dimension data because it is out of scope for this lecture and this section, because it is little bit more complicated than this 3-dimension data. So we stick to 3-dimension data only. Now how can we assess this 3-dimension data? So for example, I want to assess this one, in this case this one. So what I need to do is just specify our array which is 3dim, and first specify our outer dimension. So this is 0th and this is 1. So I want to access from one block or one column, one bigger array, and in this block on this bigger array I want to access this first row, because I want to access this first row or 0th row, this because this one situated in this first row. So I specify first here, and I want to specify this 4th column, so I write 3 here. So this is how indexing work in 3-dimension array. First we define the blocks we want to access, these bigger blocks that's separated by this space, and second we define the row and column we want to access, same as 2nd-dimension array. So when we run this, we get 1, sorry 0. oh sorry, zeroth row was zeroth indexing. So we get 1 because in one block, means this block, we get our zeroth row, which is this, and our third column, which is this. So this is how we can access the data in our 3-dimension array. So that's for all this tutorial, guys, and practice this a lot because it is a crucial concept in PyTorch also, because in PyTorch we need to access some specific elements in a tensor or array. So that's why you need to practice this a lot. Okay, then I also share this Google Colab notebook in these resources of these lectures, so don't worry about them. And you can also practice alongside with me while watching this tutorial. So closing this lecture. So until then, bye bye and keep learning, and meet you in the next lecture where we continue our this math section which I accidentally erased. So